high yield concept is to recall that we have somatotopic representations. And in particular, we have, if you go with foot, leg, trunk, arm, and hand, here we are in primary motor cortex in the purple. We have leg and foot on the mesial wall, medial surface, trunk, arm, and hand sort of extending out, and then face and mouth extending out laterally and further inferior as you go along that precentral gyrus. Then we have a premotor cortex, which also has roughly a somatotopic map, foot, leg, hand, arm, face, mouth. And then on the superior frontal gyrus, supplementary motor areas, we have leg, arm, face, another somatotopic map. And this is important to relate to if you have, for instance, a stroke that were to take out the ACA, the anterior cerebral artery. Recall that that is going to wrap up along this pericallosal region and have a pericallosal artery and a supramarginal artery, and is going to be supplying the territories that are mostly covering this leg foot region. So if you have a patient who has a deficit with their left leg, you might be thinking right mesial cortex and an ACA type of stroke there. Versus if there's a MCA stroke, middle cerebral artery, that's going to be covering more of this lateral surface. And if everyone puts their hand out like so, if this is going to be the distribution of the middle cerebral artery, if you take your hand out, put the palm of your head, hand just above your ear, and wrap it over your head, that is roughly the distribution of the MCA, middle cerebral artery. And so with MCA strokes, as we heard about earlier, you're going to have affecting more the face, hand, arm type of regions rather than the lower limbs. And that's evident based on this rough topography of the brain. Okay, so the motor cortices. More specifically, we have a new color scheme now, but we have the motor cortex, we have the central sulcus, indicated if you can see my cursor moving. The red colored cortex is along the precentral, which is where our primary motor cortex is located. Anterior to that is our premotor cortex, and then superior and mesial to that, supplementary motor areas. Now these areas, I'll discuss them each sort of individually, but think of them as kind of working together. But if you go back to Dr. Butani's lab and she were to open up your skull and put some electrodes in there and stimulate, we're going to find that stimulation is going to elicit in a awake behaving patient a non-preventable discrete motor movement of one or small group of muscles. So if I were to stimulate in my right motor cortex right over the hand region, zap, stimulate my hand, zap, stimulate. I'm going to say, okay, don't move my finger, zap, can't prevent it. It's not preventable. And it's crossing, so right side again, controlling the left side of the body. And all the movements are contralateral except for tongue, masseter, pharynx, and some of the oral features and muscles. Now, lesions to primary motor cortex initially will lead to a flaccid paralysis, but then it's going to resolve quickly to hemiparesis, mild spasticity. And you're going to have most evident problems with fine, skilled movements. Now, one of the interesting things that Dr. Jackson here back in the 1900s discovered is you can have individuals with seizures where a seizure may initiate, say, at the finger on the left hand, and the seizure would start to cause the body to move, and it would propagate up to the arm, and the arm would go to the upper arm, and then to the neck, trunk region, and then might actually cross over to the other side of the body, and it goes along this nice somatotopic map. And that was one of the first clues that we had that there is a somatotopic organization in motor cortex, or mototopic organization in motor cortex. And so that's referred to as a Jacksonian seizure when you see someone who has a seizure where the spread of the epileptic motor spasticity just spreads along a mototopic map like that. And here is the homunculus. I call him Freddy. I think it looks like a Freddy. If you were to take the amount of cortical real estate that is devoted to the various parts of the body, you've got enormous representation of the tongue, enormous representation of the hands, because as we creatures are very much about using our hands. And you can see the trunk and so forth is much less relative amount of cortical real estate devoted to control of motor movements in that regard. So that's our motor homunculus. Then in premotor cortex, in the blue area up in here, You can stimulate up in here. Thresholds are higher to get a movement, but the movements are slower, larger groups of muscles involved. If you lesion, no paralysis or reflex changes unless you also take out some of the primary motor cortex. And if you take out both premotor and motor cortices, you can get then the full-blown spastic hemiparesis. And then so in general, the premotor cortex is thought to be important for movements guided by external stimuli. So if I want to reach out and grab my pen, let's go ahead and initiate that movement. Boom, I go and do that. These areas are required for that initiation. The third area, the supplementary motor area, SMA, mostly in the purplish color here and on the mesial surface. Here's our paracentral lobule, for instance. And stimulation in these regions are going, in the red, sorry, up in here. Stimulation is going to cause assumption of posture, so stimulate, and you might have a full trunk type of movement, turning the head and the trunk. Sometimes you can cause vocalizations. You can even lead to speech arrest. So there's some involvement, some more fundamental elements of speech processing here, or speech production rather. And so this is thought to be more involved with the planning and learning of complex intrinsically generated movements. Okay, so here we have a coronal image, a T2, and just looking at some functional landmarks for review here. So in green, we have our central sulcus, and our paracentral lobule is going to be on either side of this, a precentral gyrus depicted between the green and the blue line, and a postcentral gyrus between the green and the red line here. So those are running along the central sulcus, going superior to inferior, and immediately in front of that, our frontal cortices are going to be running more anterior posterior, and here this orange line is delineating, for instance, our superior frontal gyrus from our middle frontal gyrus in an image such as this. Another important feature is the hand hook. So it turns out, so for us, this is our central sulcus on the right side, and you can see this little omega here. The cortex often, in many individuals, is going to have an actual shape like this. So you can actually surgically, when you take off the skull plate, you can sometimes see what is going to be this hand hook region. Of course, as Dr. Vitani mentioned, you want to make that, keep that as eloquent cortex as possible, since we are all about using our hands. And this is often an anatomical feature that can be seen visibly. Of course, better is to map it out using functional MRI, but if you don't have that option, here you can see it in many individuals.
Hey everyone, Ryan Rad here from neurosurgerytraining.org. If you like that video, subscribe and donate to keep our content available for medical students across the world.